All right, good day. As we wrap up our look at the mole, this is a more exotic, action-packed mole conversion sheet. The original one just had these three locations that we said were like Hope, Yale, and Boston Bar. But you can see recently we added in molarity, and even more recently we added in molar volumes. So these conversions have to be automatic. So the early kind of questions involve going from particles to moles to mass, or mass to moles, or moles to particles, that kind of thing. Then we applied our understanding of things like moles and mass into dealing with empirical and formulas and percent composition. More recently, we did questions related to concentration and volume, and the nice simple ones only involved the triangle, remembering volume and liquids. But the more exotic questions said, hey, if I have a concentration and volume, what mass do I need? So we had to figure out N which is moles, and then we had to follow our roadmap to arrive at mass. The other type of molarity question, the two-parter, was if I gave you a mass and a volume, and I said, hey, what concentration do we get? So we have to go to moles first, and then solve for concentration. Or I could give you a mass and a concentration, say solve for volume. So you have to go mass to moles, and then your moles divided by concentration would give you your volume in liters. And probably the simplest thing you've run into are the STP RTP conversions. If you're going moles to volume in liters, you multiply by the molar volume. And if you're going from volume to moles for a gas, and it's an STP or RTP, you divide by that molar volume. You don't have to memorize things like Avogadro's number, it's given. And the STP and RTP molar volume values will also be given on a test. But it's really important to remember the processes. So you do not get to use this sheet on a test, but you are allowed to use it as you're learning, trying to orient what you're up to as you tackle these kind of questions.